This is my 4-stroke compressed air engine, and as you just heard, it is quite powerful, revving to over 6,000 RPM. However, it had some pretty major flaws, which is why I built a version 2. This engine is not only easier to build, but is way more efficient and is way more entertaining to run. So in this video, I'm going to show you how I designed it, how I built it, and also I'm going to be pushing it to the absolute limit to compete with other YouTubers. Welcome to the channel. My name is Axel Dayton. Enjoy. So first off, why build an entirely new engine anyway? If this one was super powerful, why not just use it? Well, the first reason is the engine wasn't that efficient, revving to over 6,000 RPM at 60 PSI and only for 5 seconds, which is not very optimal. Second off, it was designed like a Formula 1 engine, which is what made it so inefficient. And because I want to build an RC vehicle out of this engine, it has to have high torque and low revs. So this engine, in the first place, wouldn't be capable of this job anyway. So how was I going to achieve this seemingly impossible task? Well, I did some research, and turns out the most fuel-efficient cars, say for example the Prius, run off of a cylinder displacement of about a 1-to-1 ratio, which means the width of the piston is the same as the distance at which it travels. Seems simple enough, right? So I picked my displacement to be 13 millimeters wide with a 12 millimeter stroke. This would mean it's 2 cc's, which is the same displacement as Tom Stanton's original version 3 engine. This also means that the super long stroke will force the engine to rev lower and in turn make it way more efficient. So I've been talking a lot about efficiency, but really what does that mean and how is that important? Well, in this engine there's a 2-to-1 camshaft ratio that actually drives the cams, which in turn opens the valve and lets air into the engine. But the thing that makes mine unique is the 2-to-1 camshaft ratio. This allows the motor to fire every other stroke and allow the engine to use half as much air with the same amount of power output, just like in a car. So the last major change I made to the engine was the use of pneumatic fittings instead of a direct printed on bottle cap. This allowed me to be able to use the tubing as a makeshift throttle by just squeezing the tube. This would in turn make the engine able to idle lower and in turn make it more efficient, running for a longer period of time. So because I'm American, I'm not technically the smartest breed of evolved monkey, and I ended up buying NPT threads. And there's nothing wrong with these threads, they're very good. They're what I use for my jet engine fuel system. But on the other hand, my software doesn't actually support NPT threadings. Just like how 91.1% of you guys are actually subscribed. And if you guys were to do that, it would tell YouTube that you guys enjoy seeing my content, and it'll also tell me what videos you guys seem to like. So with that, it only takes 2 seconds, and thank you very much for doing that. So to compensate for my stupidity, I instead started printing these little like block things, which are actually test prints for the cylinder head. So I was able to get my own thread design to work in this. It seals super well, ball valves in there, but also this design, I think is the final design. It barely leaks at all, and I bet with some lubrication it'll seal even better. Just listen to this. I think that'll work really well. This is like my version 6 valve head. So it's time to print out the whole engine. Now, there was supposed to be a pretty cool time lapse here, but because I was dropped as a child, I'm a complete idiot and I don't know how to set up a GoPro right. So, whoops. Anyway, with all of these parts now printed out, I'm going to show you how to build it in a 20-second build montage. If you want a full-length build video, I'll be releasing one in 1 week that'll go into way more detail on how to build this engine. But with that, it's time to test the engine. Alright, so here's the first test. I have the version 1 engine right here. This is the one without pneumatic fittings. Then I have the version 2, which, for comparison, is actually a whole lot lighter. Like, really, you could feel a massive difference in between the two engines. The version 2, the one that's a lot lighter, it's got a longer stroke, smaller surface area, all that good stuff. But it also has a much better tuned push rod. So here's the first test. First test, 3, 2, 1. Yeah, so look at that. This one runs at nice and low pressure. That's really good to hear. It's also a lot quieter too. And that thing this actually runs more efficient than the 2-stroke. Like, look at this. No cuts, no nothing. Look at that. Holy mackerel. That is very reassuring after so many weeks of hard work. Okay, that's pretty rock hard. Here we go. Yeah, so look at that. That works quite well. Alright, so the next test I'm going to do is, I'm actually going to be doing a duration test because this engine, as we've already seen, runs quite well and it sounds quite cool. But really, how much better than the version 1 is this engine? So that's why I'm out here. I'm going to be testing this bottle at 60 PSI, which is the same pressure Tom Stanton did. But you guys are probably going to click off or skip through this next part. So let's quickly get into this. Okay, here we go. 60 PSI. That is 60 PSI on the spot. Here we go. 3, 2, 1. Okay, so however long that was, timestamp is down there, just like normal, but that was really good. I think that was, what, about 25 seconds? So automatically that's almost 4 times better than the version 1 engine. However, it's not quite at Tom Stanton level stuff. So this time, I'm going to slightly squish the air intake so that I will hopefully have a longer run time. Okay, that is 60 PSI with throttle. Here we go. I can't get over how realistic that sounds. That is insane. Also, another positive of this engine, it runs quite low. So if in the next video when I put this in a remote control vehicle, it'll actually be quite practical because this is a lot more air than the last engine used up. So what do you guys think? Is this a massive improvement? Personally, I think that the engine is now the closest to being able to build an air-powered vehicle. But as much as I love these air engines and how satisfying they are to build, I do want to make some more diverse content besides just these cute little things. So that's where you guys come in. The thing is, I want to feature your guys' video ideas as much as possible because, let's be honest, without you guys, these videos would not be possible. So that's why in the last video, I asked you guys for your video ideas, and the person with the most like comments was Alexander He, who suggested building a 3D printed speaker, which honestly, I find really cool and I'm looking forward to building. So with that, make sure to comment your video ideas because who knows, maybe your idea will be featured in the future. And also, down in the comments, make sure to like other people's ideas if you really want to see that because otherwise, I don't know which videos to make. Also, what are your guys' opinions on me doing weekly videos in the form of YouTube Shorts? Now, I'm not really keen of it, but if you guys would like to see more behind the scenes and maybe some tests to videos, or maybe like some sneak peeks or something like that, I would be fully willing to make a YouTube short once a week to be able to announce my what I'm working on for a future video project. But if that's not in your guys' interest, just let me know. With all of that, if you want to build this engine yourself, the Thingiverse files will be found down below in the description, as well as the link to the build video when I eventually release it. Also, while you're down there, make sure to leave a like on the video, as well as comment your video idea, and also, please press that share button, as it seriously helps small channels like me out an absolute ton. And with this, sadly, this is all I have time for this month. I really thank you guys very much for watching, and I'm looking forward to putting this engine in a new vehicle. So with that, see you guys later, and goodbye.